We think of them as separate nightmares, the ground that betrays us, shaking our world to its foundations, and the mountains that explode, breathing fire and burying civilizations. For all of human history, these have been two of our greatest fears, two distinct and terrifying forces of nature. But what if they're not separate at all? What if, deep within the planet, they're communicating? Scientists are now uncovering a mysterious and often deadly connection between Earth's most destructive forces, a secret conversation written in fire and rock. And understanding that conversation could change everything we thought we knew about our planet's awesome and terrifying power. On one hand, you have the earthquake, a sudden, violent release of energy that ripples through the Earth's crust. It's a force that can level cities in seconds, trigger devastating tsunamis, and reshape landscapes in the blink of an eye. The terror of an earthquake lies in its unpredictability, the sudden realization that the very ground beneath our feet isn't as solid as we believe. Stories from across the ages tell of the ground opening up, of buildings crumbling to dust, and of the frantic search for survivors in the aftermath. It's a stark reminder of our vulnerability on a planet that is constantly in motion. On the other hand, you have the volcano, a gateway to the Earth's molten heart. Volcanoes can lie dormant for centuries, becoming beautiful snow-capped mountains and lulling nearby populations into a false sense of security. But when they awaken, they unleash a fury unlike anything else. Rivers of lava incinerate everything in their path, while colossal clouds of ash can block out the sun, disrupt global travel, and alter climates. The story of Pompeii, frozen in time under a blanket of ash from Mount Vesuvius, serves as an eternal testament to the volcano's power to both destroy and preserve a moment of sheer terror. For centuries we saw these as two separate monsters, one born of shaking rock, the other of fire. We studied them, we feared them, and we told stories about them. But the truth, as it turns out, is far more intertwined and far more fascinating. They aren't two separate stories, but two sides of the same epic geological tale. To understand this secret connection, we need to journey deep inside our planet. The ground beneath us isn't one solid piece. It's a dynamic, shifting mosaic. The Earth's crust is broken into massive slabs of rock called tectonic plates. Think of it like the cracked shell of an egg. These pieces, some the size of entire continents, are constantly moving, floating on the semi-molten layer of the mantle below. Both volcanoes and earthquakes are primarily caused by the movement of these tectonic plates. This process, known as plate tectonics, is the hidden engine driving our planet's most dramatic events. These plates interact with each other in three main ways. They can pull apart, creating new crust as magma rises from below. They can grind past each other horizontally, a violent friction-filled struggle that builds up immense stress, and they can crash directly into each other. It's at these boundaries, these colossal crash zones, where the planet's full power is unleashed. The stress from these movements builds and builds over hundreds of years until, suddenly, the rock can't take it anymore. It slips. That sudden slip is an earthquake. But the story doesn't end there. That same movement, that same incredible force, is also the architect of volcanoes. The link isn't a coincidence. It's a direct consequence of this grand planetary dance. So how exactly does the same process create both a catastrophic earthquake and a fire-breathing mountain? The most dramatic examples are found at subduction zones, where a dense oceanic plate collides with and is forced to slide underneath a lighter continental plate. As the oceanic plate plunges deeper into the Earth, the friction and stress between the two grinding plates can trigger some of the most powerful earthquakes on the planet. But as that plate dives deeper, the intense heat and pressure cause water trapped within its crust to be released. This water seeps into the overlying mantle, dramatically lowering its melting point. Rock that was once solid begins to melt, forming vast chambers of magma. This magma is less dense than the surrounding rock, so it begins a slow but relentless journey upwards, pooling in chambers beneath the surface. When the pressure becomes too great, it forces its way out, resulting in a volcanic eruption. This process is the engine behind the infamous Ring of Fire, a nearly 40,000-kilometer path around the Pacific Ocean where the vast majority of the world's earthquakes and volcanic eruptions occur. But the connection is even more direct. A massive earthquake doesn't just happen in isolation. The shocking release of energy sends powerful seismic waves vibrating through the Earth's crust for thousands of kilometers. Scientists now understand that these waves can directly interact with a volcano's plumbing system. If a volcano is already in a primed state, its magma chamber full and pressurized, these seismic waves can act as the final trigger. The vibrations can cause the magma to slosh around, a process that can cause dissolved gases to rapidly form bubbles, much like shaking a can of soda. This sudden increase in pressure can be enough to kickstart an eruption. The earthquake effectively gives the volcano the final push it needs to blow. This isn't just theory, we've seen it happen. History is filled with dramatic examples of this deadly partnership. Perhaps the most stunning example happened in Chile in 1960. The Valdivia earthquake, the most powerful earthquake ever recorded at a staggering magnitude 9.5, ripped through the region. Just 38 hours later, the Puyehue Cordon Caule volcano, located hundreds of kilometers away, roared to life in a major eruption that lasted for weeks. For many seismologists, the timing was too perfect to be a coincidence, and it's believed to have been triggered by the quake. In fact, studies of that period found that volcanic activity in the year after the Great Quake was up to 4 times higher than normal, with 6 or 7 different volcanoes showing increased activity. In 1840, a powerful magnitude 7.4 earthquake struck near Mount Ararat in what is now Turkey. Within moments, the mountain, which had been quiet for centuries, unleashed a violent phreatic or steam-driven eruption. This triggered a catastrophic landslide and pyroclastic flows that obliterated a village and a monastery, causing up to 10,000 fatalities between the quake and its aftermath. And sometimes the response is incredibly fast. In Hawaii in 1975, a magnitude 7.2 earthquake shook the island. Less than an hour later, a brief but notable eruption began at the summit of the Kilauea volcano, likely triggered by the intense shaking. These events are the Earth's own forensic evidence, showing that earthquakes and volcanoes are locked in a complex and often destructive relationship. Understanding this connection is anything but an academic exercise. Millions of people around the world live in the shadow of active volcanoes located in seismically active zones, from Japan to Indonesia, from the Andes to the west coast of North America. For these communities, a major earthquake isn't just a primary disaster. It could be a warning sign of a secondary fiery threat. Today, volcanologists and seismologists work hand in hand, using a vast array of sophisticated tools to monitor these restless regions. Networks of seismometers listen for the faintest tremors that could signal moving magma. GPS stations and satellites measure tiny changes in the ground surface, looking for swelling that indicates a magma chamber is filling up. Gas sensors analyze the air for telltale volcanic gases like sulfur dioxide. When a major earthquake strikes near a volcanic region, monitoring efforts go into overdrive. Scientists immediately analyze data from nearby volcanoes to see if the seismic shock has caused any changes in their behavior. This enhanced surveillance can provide crucial, life-saving warnings, allowing for evacuations before an earthquake-triggered eruption occurs. We're even using artificial intelligence to sift through massive amounts of data, helping to detect patterns of unrest that human analysts might miss and giving us a clearer view of the dangers below. The story of earthquakes and volcanoes is the story of a living, breathing planet. They aren't isolated monsters, but expressions of a single unified force, the relentless movement of tectonic plates, the same slow, unstoppable march that builds mountains and forges continents, also unleashes the fury of a ground-shattering quake and the fire of an erupting volcano. They are a constant reminder that the Earth's surface is not a static stage, but a dynamic and sometimes violent arena of creation and destruction. The mysterious conversation between them is one that scientists are only just beginning to decipher. By listening closely to the rumbles deep within, we can better understand our planet's power and learn to live more safely on its ever-shifting surface. If you want to continue exploring the incredible forces that shape our world, make sure to like this video and subscribe to our channel. You won't want to miss our next journey into our planet's greatest mysteries. Thanks for watching.